Hi, Paul here, and I'm working on this Powerstat here, and this unit was in excellent shape. There's the cover for it, and you can see that it's a Powerstat. Okay, I don't know if you can see that. It's a Powerstat type 116, one phase, 120, 50, 60 hertz. Output voltage 0 to 140, and it's 7.5 amps, or with a maximum of 1 kilovolt amp. It's by Superior Electric Company, Bristol, Connecticut. This unit was in really great shape. Right now I'm going to do a demonstration, and then I'll let you know what I did to it. So we'll just plug in some power leads here to my voltmeter. Okay, and voltmeter back in the shot here. Excuse me. Okay, so if I turn the unit on, I'm down at 0 volts, as you can see there. And let me get that a little bit better. Glare from the light. All right, too much glare from my lights above. Hold on a sec. There you go. Okay, so as we rotate the rheostat, you see I'm going up very slowly. And this is the contact here for the voltage across the rheostat as it turns around the coil. So we're at 12 volts. And it's nice and snug, as you can see. 40, there's 52 volts. Still climbing fine. 66 volts. 76 volts. 83 volts. And you can see that it's doing fine. Now approaching 115. And you can see I'm still got considerable way to go. 121. 130 volts. 143.8, and the max is 146 volts AC. Now my power source here is roughly 120 volts, so that affects the high-end voltage. If yours is lower than 120, you'll probably push around 135 to 140 if you're pushing out around 115 volts. AC, I'm putting out at 120. If you're putting out anywhere around there, you're going to get up to around 145 volts. It's rated at 140, but it gives you considerably more. Okay, now let me show you what I did to the unit. All right, I took the cover off and the knob, which you can see is in great shape. And you can see how clean the unit is. It has the, let me go ahead and unplug it so I'm even more safe here while I touch things. It has the serial number on it there. This is the actual contact. This contact was bottomed out. The screws here were needed to be reset, so I need to drop the plate. I dropped the plate down a little bit, and you got plenty of contact left. You can see the contact in there. Put the light back down. There you go. See, you got, the contact is hardly even worn. It was just beginning to come up off of the coil, and now it's got good pressure. It's back where it belongs. Also, I cleaned the coil, the tops of the coil. As you can see there, they were pretty black. with carbon buildup from the rheostat, but they're now in good shape. All the coils are connections are great and clean. I know you probably can't tell all that in the video, and excuse the tilting and everything of the video. I'm doing this by hand so you can see what we got in there. But you see how clean that copper trace is. Look, you can see the shadow as the light shines through the holes in the top from my fluorescent light up there. Everything is clean. And I was just off camera, we'll do this, but this dust in here, I'm getting that out of there. That doesn't affect nothing. That's just dust that was trapped in the housing. But I'll get all that out and clean it up. But look at that coil. It's in very good shape. No dings, no bad spots. The coil's fine. Top plate also says Superior Electric Company, Bristol, Connecticut. So it's got everything in place. And this, like I say, is now nice and tight on the coil. So as you turn it, if you turn it fast, you'll hear some wiggling. That's the contact moving back and forth in its housing. That's normal. It's actually well, let me show you so you'll know what I'm talking about here. Let me get this. If we take that out, you'll get to see how this mechanism works. This is the most crucial part of any of these rheostat connections. One is the top of the coil, and two is the contact. But this contact goes into, this is a cast aluminum housing here, so it fits in there pretty snug, but it's brass and it has a little bit of play, front and back, left and right. That's by design. The hole here is a little bigger than this, and of course when you brass against aluminum, you're going to hear it, right? But you notice, okay, right here, that holds the contact in the worst possible case, which is all the way up. If that wasn't touching on the coil, assuming this was the coil, that wasn't touching or was intermittently touching, you'd have no voltages at different places. You'd have bad spots. So when it's pushed down like this, you see they give you, well, it's hard for me to do it with one hand, but they give you that much play. There you go. And that, you don't want more than that. You don't want that much, because that's too much pressure on the contact and it would wear it out too fast. Nor do you want it way at the top, because like I said, that would be an intermittent contact. So I adjusted that by adjusting the height of the gear, the pulley here, so that when I tighten the screw, you see it's at worse shape there, I tighten the screw, and see it gives you plenty of contact on that, down on the bottom down there. Plenty of pressure to hold that contact against the coil. That was, like I said, that's one of the parts that wears out the most on these, is that contact pressure. It drops away as the contact is worn down. But this contact's in great shape. It had probably not been adjusted at all, because it was, if you see, it still has a very defined point on that contact. It's, you know, it's got a little flat spot. That's supposed to be there, so that it can rub on the flat surfaces of the contact of the coil. But when they're worn down, that contact would be almost flat and very worn. There wouldn't be no triangular shape left to it. So this contact is in good shape. This coil's in good shape. You may think that the coil is worn as well. That's not the case. That is done by design. Again, you need a flat surface that is going to make a good contact with the flat tip of the contact that comes down. So and the other thing is the discoloration. That's bare copper. these copper coils are coated so that they don't short out against each other. But up here, that coating is removed, and the copper is smoothed, actually flattened, yet maintains a very narrow spacing between all of the field windings of the coil, so that when the contact turns, it's never hitting more than two, or actually I don't even think it would hit three, but two of the field coils at a time, max. So that gives you a very gradual increase in voltage as you turn. It's rated at 7.5 amps with a maximum of 1 kilovolt amp. So it's pretty strong transformer, in good shape. Now, this transformer was mounted on a base that I haven't cleaned up, a wood base somebody made for that and painted it black. It looks pretty good. And they put a felt bottom on it, which is really nice. I'll wipe it clean, but I'm not going to repaint it or anything, and put it back on there, and I'll show you the finished product when it's all back together. But anyway, what I did is clean the coil, adjust the contact, still doing a little bit of cleaning around different areas, like I say, getting the dust out of there. You see how it moves, it's just loose dust. The box has a 2-prong AC output. It is a vintage unit, it's not grounded. And I'll show you the plug. It's a 2-prong plug with 1 prong being silver and 1 being brass, and silver in color. That's so you know that that's the neutral. So if you wanted to plug it into a modern outlet, you know that the wide outlet on the plug would be the neutral, and that's where you would plug this in. It is not an isolated transformer. None of these are. That's a mistake a lot of people make. They think that rheostats are isolation transformers. They're not isolation transformers. That neutral is actually passed through. So, and they're not grounded. So, be aware that you're running right off the 120 line. This coil goes across the 120 mains. So you're not isolated in any way by using a rheostat. You need an isolation transformer in addition. This is a newer model than the one I'm using. I'm using an old rheostat here, which is connected in this box, and I got it connected with a light backup, but I also have in the box an isolation transformer. So I am backed up by a current limiting light bulb. I also keep one of my outlets connected to a voltmeter, so as I adjust the voltage, I know what voltage I'm using on my output. But by having an isolation box like this with an isolation transformer and a rheostat, you protect yourself and your equipment, which you don't want to blow up, from your circuit as you're working. And to test for shorts, I can turn this on, and the bulb will light. And if the bulb light's real bright, then I know there's a short in the circuit. If it doesn't light bright and everything seems okay, then I can shut the current limiting off and have full voltage going to whatever I'm working on. That's what you would ideally want to do with something like this. You would want to put it on an isolation transformer. Anyway, I'm going to finish cleaning this and assembling it, and then I'll add to this video a final picture to show you how it looks. And you'll see it's a really clean looking device. It's in great shape. Okay, this is Paul, and I got this rheostat, Powerstat back together again. It's like a Variac, it's the same thing. And I got it back hooked up to my power. I also got it hooked up to a 100-watt light bulb. You can see that small print, but so yeah. Anyway, that gives us a load. All right, so let's do a test. So I turn it on. and it's right now at 1 point, well, just under 0. If we pull the voltage up, and I'll show you what we got going here. Let's set it right at 60 volts. Yeah, and we're showing 64.1.2. And again, this was made back when mains were around 117, 115 volts. And I'm pulling a good hefty 121 to 123 volts on my mains. So the voltage of 64 while I'm on 60 is about right for 120 mains. It's always going to be a little bit higher if you got modern mains, because this is a vintage unit. That's why I use a voltmeter. You can get it whatever you want. I can pull it down to 160. And I'm picking this number at random, half of the 120. Okay, so right about there, we're about 60 volts, and that's showing 56 on the dial. So maybe 56 and a half. So, you know, there's a little bit of variance depending on your mains voltage. And what I want to do now is put it on the 120 mark, which you see is, for me, is 127 volts. So there's a lot of variance there. If I pull it down to 120, and there, okay, I'm on 120 volts, and now I'll turn on, I got this 100-watt bulb, and watch the meter. Okay, so pulled it down to 118, about 118.6, 118.5, shut the light off, 119.6, 118.8. So the power drain on the rheostat doesn't really change the voltage much. It's really steady. I mean, that's less than 1% variance at a 100-watt bulb, even pulling through this cable, which I'm sure has got a pretty good voltage drop across it. And yet we're still doing all right. Now, if I had a three-way, I could have pulled a little bit more current, but anyway, it's working fine. It's putting out its voltage. Has a fuse holder there that's rated at, I believe, 8 amps. Yeah, 8 amps. So I know you can put something low. I think there's a 3.3 amp in there now. I don't know. It was in there, and I just left it. But it's working. So if we shut that off, unplug it, I'll show you the base that's on. Somebody made that base for it. It's pretty cool. It's made out of a 3/4 inch plywood stock, I would guess. Maybe regular 3/4 inch wood stock. But painted black. But they put this felt on the bottom, which is a nice feature. Picking up lint from my bench here, but it's wiped off. And showing a lot of discoloration, but that's just the fluorescent lights in here. The actual unit is in really good shape. You see the finish on that? It's in really good shape. This unit has not been used much. A few little scratches here and there. You know, I think the worst one is right there on the front, on the top, on the edge. Again, very minor. Now, if you know your mains voltage and you was interested in this and wanted to adjust it, you could definitely do that. Actually, what I would do is put it on a voltmeter, run it up to around 60 volts, and if you're up, down, or low, you can loosen these screws in the knob here. There's two. There's one there, one here. There's about 30-degree angle from each other. You can loosen them, and the knob will turn loosely. So you could set it at 60 volts and then set it where you want it, tighten the screws down. And That way you'd be calibrating it to your mains. So that would be the procedure to do that. Anyway, again, thank you for looking at my video, and appreciate any likes or comments or sharing that you feel fit. I will go ahead and wipe this cord down. It needs to be wiped down. I haven't done that yet. And it'll be cleaned up and ready to go. Again, light scratches. Not too bad for something of this age. Again, thanks for watching my video.